Okie doke, on to day 2 of 6.2. We're eventually going to get to Newton's law of cooling, but we're going to start off with some review about some investing. So we're going to invest a couple different ways. If you look at the first one, interest is compounded continuously, and then it's monthly, and there's different cases that you have. You could have annual, daily. So let me show you these two cases. So if you're compounding interest continuously, you're going to use a formula very similar to what we used the day before. If you guys look up here, we were looking at this a lot, the exponential growth, y equals c e to the kt. We're going to use something very similar. With money, a lot of times I think of it as PERT, where this is the principal, your initial amount. Remember yesterday we looked at the initial and it was the 2.314, which is the C. We're going to call that P for principal, and instead of K, which is your constant of proportionality, we're going to call that our interest rate. Okay, so we're going to call this the formula PERT. Okay, let's start reading through it. We invest $20,000, so that's our principal, into a savings account in which interest is compounded continuously. Now, we already pointed that out. That's how we know to use PERT. The annual interest rate is 5.5%. We have to move the decimal over twice, so we get 0.055 T. How long? I know I'm allowed to keep T because it says how long to double your investment. Y is what you end up with. So if you start with 20, you're going to end up with 40. I'm trying to get to T. Let's divide both sides by 20,000 and get here. Do you guys notice this is no calculus really? Take the natural log of both sides. The reason we're doing that is to bring that exponent down. Let's take T, divide both sides by 0.055, and ta-da, we're done. So go ahead and pick up your calculator. When you guys type this into your calculator, when you type the natural log button, a parenthesis automatically generates. So I recommend that you go ahead and type natural log of 2, hit enter, and then hit divide by that. Or after you type natural log of 2, close your parenthesis. Okay, either one, but make sure that you get to 12.603. So we're going to have 12.603 years. That's how long it will take if we invest 20,000 with that interest rate to double what we have. Okay, on to 5. We are no longer compounding continuously. Now it's monthly. Okay, this is going to be kind of similar. Let me pull the other formula up from above. So what we end up with is on the left. We want $1 million, so we're going to put $1 million here. The question now says find the principal. So we have to say, what should we start with? Like, what should we invest now? So that's our unknown. Now, instead of PERT, we're going to do 1 plus, you're going to take your interest rate. So again, you guys saw this the last 2 years, but you just may have forgotten. Your interest rate is 0.06. You're going to divide it by how it's compounded. So because this is compounded monthly, we divide by 12. You're going to raise it to the power of, normally it would be like the years, but because we're doing this for 40 years, 12 times a year, it's going to be 12 times 40. Go ahead and type this in. So we have $1 million. If you type everything in right here, you're going to get 10.957. And again, please don't use 10.957. Use the whole string on your calculator. So you're going to take $1 million divided by this whole string, and you're going to end up with 91262.08. So right now, if we want to end up with $1 million in 40 years, we need to invest $91,262.08. Again, no calculus. We're not taking integrals or derivatives. We're just kind of using our old knowledge. Okay, on to 6. We're still not on to Newton's law yet. This is the sales in thousands. Let's keep in mind that that is like that. So if they give us 8,000, we're going to use 8 because sales is in thousands. So there's the sales function. It says find S as a function of T if 5,000 units have been sold after 1 year. So what's the only unknown? Isn't the only unknown K? So let's go ahead and find K. Again, we already have our function, no calculus. So I'm going to go ahead and replace S with 5. Remember, not 5,000 because it's already in terms of thousands. 31 minus e to the K. I'm trying to get K. That's the unknown that I need. The time is 1 year. I'm going to divide both sides by 30 and get 1/6 is 1 minus e to the K. Now to make E positive, I'm going to add E to the other side, and I'm going to subtract 1/6, take the natural log to get that K out, and ta-da, there's our K. I need the equation though, not just K. So it's going to be S equals 30, 1 minus E, natural log of 5/6 times T. Okay, there's our equation. How many units will saturate this market? Okay, market saturation has to do when like the product has leveled off. Okay, so we're saying like over time, horizontal asymptote, how do we find that? Try to remember. It's when T goes to infinity. So we are going to take the limit as T goes to infinity of this function. Okay, we're going to do this without a calculator. So off to the side here, let me sketch the natural log function. Remember I mentioned this a couple times this year. I need you guys to have this function memorized so that we can use data from it without using our calculator. Natural log of 5/6. So I'm going to make some notes off to the side here. I have 30 times all of this stuff here. As T gets huge, I don't know if this whole thing is getting huge. Maybe if this is negative, it's in the denominator. So I have to figure out what's going on here. 5/6 is less than 1. So 5/6 is going to be, let's use a different color, maybe like right here, right? I'm just making that up, but I can see that the output is negative. So what I'm going to have, and this is just us thinking, right? This isn't necessarily our work. It's going to be 1 minus E to a negative T. And I am not saying that natural log of 5/6 is a -1. I'm just saying it's a negative value. Okay, natural log of 5/6 is -1, is -0.18. But I just know that it's a negative number. And let me erase that just so it's not misleading to you. It's going to be a negative times T. Okay, so if I want to rewrite this, if I have a negative, can't we write that on the bottom now? So I'm going to have 1 over, okay, so I went ahead and rewrote it already. So if you have E to the negative, that just means write it on the bottom. So I'm going to have E to some number all to the T. So as T gets huge, this whole thing is going to 0 because it's going to be bottom heavy and 1 over a huge number is 0. So if this is gone, I'm left with 30 times 1, which is just 30, but I'm not going to write 30 as my answer because it said the sales were in terms of thousands. So it's actually 30,000 units. Okay, finally, done with the review stuff. Let's go on to Newton's law of cooling. Okay, Newton's law of cooling. Do you guys see again why it's in this chapter? We have a differential equation right here. And it's saying an object at a certain temp is placed in a room at a fixed temperature. The rate of change of the object's temperature, the rate of change of the object's temperature means equal, proportional, constant of proportionality, to the difference between the current temp of the object, which is T, and the temperature of the room. I went through and labeled everything here for you also. You can also think of the ordered pair as little t, capital T. Again, math being case sensitive, be super careful. Okay, so what we're going to do is we're going to read through the next problem and try to figure out if any of this stuff can apply. Okay, let's read through it. Okay, example 7. Some AP Calc students went on to become detectives. They were tracking a wanted robber. I'm going to try to keep the stuff above visible. One day they finally arrived at his chilly apartment, which is 50 degrees. Try to read up above and figure out what's 50 degrees. Go ahead and pause it if you need to. It's his apartment. It's the temperature of the room, so it's T sub S. Then it says they were an hour too late. Okay, so they showed up an hour after, and they did find a cup of coffee that had a temperature of 70. So after 1 hour, the coffee's temperature was 70. There's an ordered pair. Remember the ordered pair, if you look up here, is time and temp. They knew the coffee was originally at 80, so that's how smart they are. That means at time 0, the temperature is 80. There was a note on the table indicated that he planned to return 4 hours after he left. Find the temp of his coffee at that time. Okay, so we're going to take this diffie Q and we're going to sub in what we can. The only thing that we can really sub in, because little t and capital T are variables, is this T sub S, and we found that to be 50. So let's go ahead and do this. We have a ton of room to work down here. We're going to use quite a bit of it though. So up above it says d capital T, d lowercase t, k, t minus 50. Now we're back to what we're used to. Let's bring that d little t to the other side. Bring the t minus 50, the capital T minus 50, to the left. Go ahead and integrate both sides. Now, throughout this chapter, I've been using u sub, and I've been writing u if it's the bottom. But let's just look at this now. Isn't this the derivative just 1? Oh, I hope you guys caught that. I forgot d capital T right there. Okay, so because the bottom, the derivative is just 1, I'm good, or it's just dt. So I'm going to go ahead and write natural log of t minus 50, and that is going to be kt plus c. Again, we've been doing this all chapter. Let's exponentiate both sides, and I'm going to get e to the kt times e to the c. Let's break off the absolute value and replace e to the c with just c. So t is c e to the kt plus 50. There we go. Now, what's unknown? We don't know k, we don't know c. That means we need two ordered pairs. Look up above. I see 080 in the screen. Let's go ahead and use 080. Okay, so this right here is a good starting point. Now we have to sub in some numbers. So at 080, I'm going to have 80 equals CE to the k times 0 plus 50. That means 80 equals C because e to the 0 is 1 plus 50. That means C equals 30. So now I have t equals 30 e to the kt plus 50. What else do I need? I need k. We have another ordered pair though. We have 170 up above here. There you can see it on the top right. So we know 170. So it's going to be 70 equals 30 e to the k times 1 plus 50. Let's subtract 50 over, and we're going to get 20 equals 30 e to the k. Let's divide by 30. That's going to give us 20 over 30, which reduces to 2/3. Almost done. Let's natural log both sides. Let's erase that. The reason we did that was to bring that k down. So I get k equals natural log of 2/3. That means t is now 30e. K is natural log 2/3 times t plus 50. Okay, we have no more unknowns except little t and capital T, which is totally legal. Now we can answer the question. What will the temp be 4 hours later when he returns? Right? I'm sure that's what he's going to be worried about. So let's go ahead and sub a 4 in. Pick up your calculators. Go ahead and type this in on your own. Pause it while you check it. You should get 55.926. So we'll say 55.926 degrees Fahrenheit is a story problem. Make sure you have units. And that should be it. Yes, we're out in under 15 minutes. Okay, guys, have a nice day.